Alright guys, I'm back. I tried recording some stuff of blowing stuff up with just 240, but nothing actually wanted to pop, so eventually I'll dig out transformer I have hiding back in there. It's 12240, 480, 10 kVA transformer. Got one hiding back in there, and I'm going to probably get another one and make my own version of photonic induction's busterfuck, because it's the best thing someone's ever made, and get 20 kVA rated. A little overmatched on the Variax, that way the transformers don't die. But today, we got a little cap bank going on, so this is not nearly all the caps I have. I've got, up there is 25 more 5 farad at 450 volts DC, and 6 at 1500 microfarad, 450 volt DC. So, yeah. I'm going to probably build a big bank in the future off of those, possibly, maybe. So you got a big cap bank here, you got a reverse voltage diode there, which it doesn't really want to do its job, but that's whatever. This was originally built for a coil gun project, I'm just reusing it. So we just have AC coming in here, bridge rectifier going into the buses. We have one lead coming off here, which is attached to a really thin alligator clip to there, so maybe the clip is going to blow up, or the capacitor. Bleed resistor here, just so it's on it at all times, and I'll just pull off that lead. Voltmeter across the bank to there, and then we got a lead coming off here into a different blow-up stick, which this one I just had to redo and actually hydraulically crimp a end onto it because it kept blowing the end off. Oops. So yeah. And for people that want to know, I know the control cabinet itself is messy, but I'll show you what actually the inside of the button box looks like, which that's a whole different story. That's what the inside of the buttons look like. This was something I was able to do and sit down and not have to change. So you have your power, or all your wires coming through 3 separate holes here, come up. All your grounds come here for all the buttons, so they're not daisy chained off each other, which I prefer doing it this way, to just a main distribution block. Come up here, split off into their runs, and then come on up. So I think that one turned out pretty good. But yeah, so that's what the inside of this button box looks like, if anybody actually wanted to know. But I'm gonna situate this all closed. I'll turn down the Variax because right now they're cranked all the way up. We'll probably put 60 volts across that bank, so that capacitor is only a 25 volt rated capacitor. And then we'll see if we can blow up that capacitor. So let me see if I can find you guys a good spot to watch it, and I'll be right back. Alright, this is honestly like a 30th thousandth take I've had of this. This is actually like a day and a half later from the intro part I filmed, because I kept blowing up bridge rectifiers. So I've got a really cheap stand right now I'm using. I actually bought new bridge rectifiers because I've actually blown up 2 of them already. So right now you're actually taped, my phone is actually taped to a floor jack because I don't have a tripod right now. So, because the one I had broke, so now I'm doing this temporarily till I get a new one. But yeah, capacitor right there. We're gonna load probably, I don't know, a good amount of voltage on the capacitor bank. I don't possess a voltmeter that's actually have fast enough current reading to be able to tell you how much current I'm dumping into it. It can't pick it up fast enough, so we're gonna dump, probably I'm trying to put about 300 volts on the, what? You're angry. Guess I ramped up voltage a little too fast. Capacitor bank started drawing an obscene amount of current, because I jumped up from 0 to 110. Over the Variax went, hey. So I looked over the amp meters at almost 50 amps. So that's 256 volts. Bump it up to 260, a good even number. Okay, I guess 265 is the magic number. Okay, 265 volts on the stack. 3, 2, 1. She's gone. Alright, let me get the next thing put on there. Alright, next up, diode versus 260 volts DC. Bank on. Now this time I'm going to remove the short wire instead of blowing it up like I did last time and blamed it on the fact I ramped up voltage too fast. Oh well, same difference. Variax at 0. Use a bit of current, make sure she's not blowing up anything. Current lines are still at 0. I bring everything up slowly on these banks because I'm still testing them out. I had a couple loose screws on the bus bar, so I don't know if you can see it, but second in from the left, there's a little bit of arc marks around the screw. These Variax get very noisy when they get to midpoint. But I love it. Okay, 267 volts versus diode in 3, 2, 1. Huh? Not bad. Next up on the chopping block is a fuse. I don't know what this one's rated at. I think it's a 15 amp fuse, maybe only. I think it's a 15. No, I'm bothering with it. I don't know. It's about to be a dead fuse, I can tell you that much. So, that on, Variax at 0, short bar is off. Good. $100 volts DC. Still basically 0, 200, 263. Present to you dead fuse in 3, 2, 1. Kabam. Alright, well guys, thank you guys for watching. I hope you like the slow-mo bits, if they turned out decent. I haven't recorded this yet. Anyways, thank you guys for watching, and I will catch y'all on the next one.